This project is on image classification, specifically about training a model that can differentiate between cat images and dog images, which are actually categorized as cats and dogs classes. So let's move forward and understand image classification. So image classification refers to the task of extracting information classes from a multi-band raster image. Depending on the interaction between the analyst and the computer during a classification, there can be two types of classification, which are supervised and unsupervised. So for this course or this project, I would say that we will be using supervised image classification. Now, before I move forward, let me just help you understand what raster images are or what multi-band are. So bands are basically telling you information about a raster, where the bands are actually representation of pixel data in the form of matrices of cell values. And these representation of pixel data comprises of raster. Now let's move forward and understand the details of the project. So first we will be using classes like mobile nets. These are actually pre-built trained models for image classification that we will be using. You can train them again or you can directly use them for however you want to. Second, we will understand if we want to build our own model, how to do that for image classification. Third, we will understand how to use Flask and use our image classification model on it. Lastly, we will deploy the Flask project on Heroku. So for the machine learning model, we start off with pre-processing the model's data using image data generator class, which is like a very useful class and has a lot of parameters on which different type of data, that is my images, can be transformed or augmented in a different manner. And then we move forward with training our model. So this is the second part of the course where we will be understanding Flask and how to mount the image classification model onto Flask so that we can build a web application of image classification. Lastly, we will be deploying the Flask application on Heroku and using connections to GitHub. Thank you. And with this, we can now move forward to the first part of the course where we will be building our model or using a pre-trained model. This is the first part of the course, which is segregated into two parts, where in the first part, we build our own model, and in the second part, we actually use a pre-trained model named mobile nets for image classification. So starting off, we import the necessary libraries and we will be using a sequential deep learning model which will be having activation and dense layers in it. Now you can see that I have also called upon conv2d, maxpool and flatten layers also. So while we will be using activation and dense for our mobile net, we will be using all of these layers when we are building our own model. Even except all of these layers, there are even more type of layers present for deep learning models, and I will be discussing more about this later on. So I've also provided the link where I actually got the data from. As you can see, this is the link that I wanted to provide you all. If you wanted to have access to all the data or the whole data set as such, since I have only taken a sub part of it and used it for training our model. Now, before I go forward, I've also provided another link to my Google Drive where I've kept the segregated data. Since if you go to Kaggle, it would provide you with all the data set, meaning it would provide you simply with cats and dogs images, and they are not segregated, they are mixed. So you have to separate them out So if you go to this link, you would see that I have built a train, test, and validation directories, where inside them you would go, you can see that there's a cat and dog directory holding each of the dataset. Now the next thing I'm doing is simply just setting up or mounting my directory to the Google Colab and going to the directory where my dataset is present. Okay, not exactly. This is just the drive directory that I am trying to go into, but you can see that I'm still in my content directory. So from my content directory, I'm going into drive, my drive. This is a directory I made for myself, and then inside cat versus dog, there's a train directory present. So it holds all the training data for me. Similarly, the validation data and the testing data. I have already specified the path, and this is done so because these paths are directly to be put as a parameter in my image data generator. Now, as I talked about in my introduction video, this image data generator is actually a pre-processing tool which is used by many people in image classification to augment or pre-process the image data. Now you can see that I have already mentioned two applications. One is for VGG16 and one is for mobile nets. So actually, this image data generator also takes another input, which you can see as pre-processing function. So if I'm already using a pre-trained class or pre-trained model, so I have to give the pre-processing function the specific models pre-trained class, that is not exactly class but pre-processing model, that is pre-process underscore input for mobile nets and similarly for VGG16, because like you can see here the target size is 224 by 224. That is telling me the width and height of the image. So let's say my image actually had uh, 900 into 900 pixel image, okay, or dimension image. And what this image data generator would do is it would squeeze the image into a 224 by 224 dimensions. Now this is actually defined for mobile nets. If you're going to use VGG16, then this target size would change. That's why in image data generator, the first parameter is to tell the image data generator which model we will be using as our pre-processing unit. Now, before I move forward, I would like to introduce you to what VGG16 and MobileNet are. The ImageNet Large Scale Visual Recognition Challenge, or ILSVRC, is an annual competition where each team can compete on two tasks. The first is to detect objects within an image coming from 200 classes, which is called as object localization. The second is classifying images, each labeled with one of the 1000 categories, which is also image classification. So VGG16 was actually proposed by Karen and Andrew of the Visual Geometry Group Lab in the paper Very Deep Convolutional Networks for Large-Scale Image Recognition. And after their input and the data they used, this model achieves 92.7 percentile top 5 test accuracy on ImageNet dataset, which contains of 15 million image belongings to 1000 classes. Now, while you must be thinking that this is a very large data set, consider this also, that this deep learning model VGG16 also has at least 138 million parameters, and that is a lot of parameters, and it has at least 16 of its layers having weights, and those weights are again and again redefined. Now, while the VGG16 is a very comprehensive model for image classification, the objective was that the ImageNet dataset contained images fixed size of 224 by 224, which you can see that is the same for MobileNet also. So the dimensions were 224 by 224 and had three channels, each for the primary color, that is RGB or RBG, BGR. Anyway, we know that RGB is basically red, green, and blue. So we had a tensor that was now created by 224 by 224 by 3 as our input. So this goes as our input and the output comes as a array of dimension 1 into, okay, not 1, 1000 into 1 as our cardinality. Meaning for each class there is a probability. Since we had 1000 classes, there are 1000 probabilities which sum up to 1. And this sum up to 1 is actually done by softmax function in my last or output layer. So let's say that we have an array of 1000 classes C1, C2, C3 till C1000. Then let's say C1 was actually 0.1, C2 was actually 0.02, C3 was actually 0.66, and the rest, okay, uh, and the rest were very minute values. This means that for an input, if I had this as my output, this means that the image was of class C3. This is because the highest probability is for class C3, and that is how we understand which of the class this input image had. Similarly is done for MobileNet also. It also categorizes in 1000 of its classes. But the good thing about this is we can again pre-train it, or I should say we can train some of the, what should I say, some of the input layers, which I can show you in, let's say, let's go down below. You can see that MobileNet has a lot of uh, layers in it. Most of them are conv 2D or max functions. And you can see that, yeah, this is my MobileNet model, and a lot of them are having a lot of parameters and input layers. And you can see that there's 4 million total parameters. Now you can see that what I've done is I've taken the last 23 layers and I'm again training them. So you can see that after I've trained them, my last layer is actually having only 2 as my class values, meaning there is only 2 classes, or else usually it has 1000 classes. So let's go above, and yeah, so VGG16 was this, and now let's come on to mobile nets. Now mobile net is also actually, I could say, similar to VGG16, but it has less parameters, it has less input layers or hidden layers, I would say, and it is much faster in training and testing as compared to VGG16. And that is the basic reason why I've actually chosen MobileNet as the pre-trained model I would use for image classification. So for more info, you can just Google this, and you can see that how these MobileNet and VGG16 have been trained, what all hidden layers they have, how many parameters they have, and much more. Now let's go forward with image data generator, because inside our image classification project, this is one of the most important part, and if you are able to understand this properly, you would be able to understand how to pre-process and when to pre-process your image before training a model. So let's go forward with image data generator. So image augmentation, oh my god. Yeah. So image augmentation is a technique of applying different transformation to original images which result in multiple transformed copies of the same image. Now this can be used in multiple ways. One way is that, let's say your dataset is very small, having only 5 or 6 images. Now if you're doing image augmentation or image transformation, then what you can do is take the first image, maybe rotate it, or maybe you can get a mirror image of it, or maybe you can change the RGB values for that image, and you can get a new image out of it. Now with this way you can actually extract more data or more images and build a better data set for your model to train on. Another thing is applying the small amounts of variation on the original image does not change its target class, but only provides a new perspective of capturing the object in real life. And the applications or the advantages of using image data generator does not only end here, as these image augmentation techniques, which can be used through image data generator, can not only expand the size of your dataset, but also incorporate maybe a level of variation in the dataset, which allows your model to generalize even better on the dataset. Now, you can see that this image data generator is actually a very important part of image classification or dealing with images as such. I've already talked about pre-processing function, where I just have to give a reference to which pre-processing unit I would be using. Maybe it might be a mobile net or maybe a VGG16. It doesn't actually ends here. It also has many other pre-processing functions, but I'm just defining both of these. You can see that the directory that I had, actually the path I had specified here, I'm sending it into the directory parameter. So the image data generator directly goes into these directories or the path and finds the images. I have given the target size that the images can be of different dimensions, but just squeeze them into this specific dimension itself. Then I'm providing it with classes, how many classes are present, since we only have cats and dogs, so two classes that I've defined here. So if a array I get, say we had a 1000 class array, so here I would only get a two class array, 0th index being cat, first index being one index being dog. And I'm telling this image data generator to build batches of the trained data, not just stuff all the data, yeah, trained data into just one, let's say box. So here boxes would be made with 10 inputs, yeah, 10 training data inside one box. Similarly, I'm doing for valid data, having going into the valid batches and test batches. Now you can see that it has found 1000 images belonging to two classes that are cats and dogs. Similarly, 200 images for my validation set and 100 images for my testing set. So next we introduce images and labels that would be used in visualizing some of the images and how this image data generator has actually pre-processed or transformed the original images. And as you can see, yeah, here you can see the actual images were not there. You can see the contrast has been decreased here. The contrast has again decreased here. The contrast again has decreased here. In each of the images, the contrast has decreased. You can see darkness here, or you can see that some of the images are like really squeezed into maybe vertically or maybe horizontally. So this is how you are actually using the image data class generator class and transforming your original images. So I'll just print labels and yeah, from this point on, we're actually building a model that would be using our transformed images for training itself. So you can see that I specified my activation function as ReLU, my input shape as this, and you can see that the 3 is for RGB color configuration, which I had already talked about in VGG16 model also. And the similar type of configuration or input shape is also used by mobile nets, since both of them are actually used in image classification. The next layer you can see is maxpool 2D, and then again a conv 2D, maxpool 2D. Now we have a flatten function, oh sorry, a flatten layer. So what this does is this actually decreases your dimension of the weights, or I should say the yeah, let's go with weights actually. What it would do is, say there's a 3 dimension or 4 dimension weight, and what this does is it decreases the dimension to just 1 dimension. Meaning if I have 300 by 20 by 3, let's say this is, so it would convert it into 300, actually not like this, yeah, 300, 300. So what this is doing is basically flattening, or I would say decreasing the dimensionality, so that I can just simply input my weights into the last dense layer. That is my last layer, output layer. And now you can see that it has 2 units. So it would be taking only 2 units because we have defined only 2 classes. And as I told you before, for last we are using our activation function as softmax. Now, before I move forward and show you how the model has fared, let me just talk about a little in depth for Conv 2D and Maxpool 2D. So, both of these layers, how do they work? So, let's talk about convolutional 2D layer. This layer creates a convolutional kernel that is convolved with the layer input to produce a tensor of outputs. Now, if you're using this as the first layer of your model, you have to give the input shape also, so that it doesn't happen that the dimensions cross this input shape. And the problem it would acquire is that the flatten might be able to decrease the dimensionality at the end. But since the image already has the input shape of this, if the starting or the first layer doesn't understand the input shape, then the model would give you an error. So basically, what happens is that this 2D layer takes in the input, specifies some part of the input. Let's say that the image is a dog image and of the size 223 by 220, 224 by 224, height and width. And the 3 is already defining my RGB configuration. But what Conv 2D is gonna do is it will take a sub part of that image and extract more information out of it. So if we go by the parameters, you can see the first parameter, filter. So filters is the dimensionality of the output space. That is the number of output filters in the convolution, and which is given by 32. Now we already had only this as our dimensionality, and it asking it to increase it and set it to 32. Now you can see that the next is strides. Oh, sorry, not strides, kernel size. Stride was for Maxpool 2D. Yeah, so kernel size. So basically, this kernel size is an integer or an tuple specifying the height and width of the 2D convolutional window. So just like I told you, let's say there's an image of 224 by 224 height and width. What happens is what happens is that now a kernel of size 3 by 3 height and width will be built and that small kernel is going to take a subpart of the image itself and work upon it or extract more information from it. So this happens for each image, where this kernel divides the image into a number of subparts of size what we have defined here as my height and width, and then extracts information out of that subparts itself. Now we can go for the next layer, that is max pool 2D. So the max pool 2D is basically downsampling the input along its height and width by taking the maximum value over an input window defined by my 2D convolutional layer. Now the window shifts by strides along each dimension. So what happens is, we had already defined my window as using the kernel size, and now I'm using my strides to shift the window itself. So you can say that there's a very large rectangle and there's a small square at the top right corner of the rectangle, and I'm asking to shift that small square two strides, or basically let's say 2 units to the left side or 2 units to the right side. So what this is what it is doing. And next you can see that there's a pool size. So pool size is actually the window size over which to take the maximum value. If we have specified 2 comma 2, it will take the max value over a 2 cross 2 pooling window. If only one integer is specified, then the same window length will be used for both dimensions. So if I only specify 2, it would be same as 2 comma 2. But if I am writing 2 comma 1, then it would be taking a dimension of 2 cross 1 units. I'm going to remove this. Yeah, so this is how we have built a sequential model having these layers. And this is a very basic model, I would say, having very less layers and less number of parameters. Now you can see that I'm compiling the model using my Adam optimizer with the learning rate of 0.001 and using a loss for categorical cross entropy. Now, since we already know that we have only two classes, that are cats and dogs, we can also use binary cross entropy true. Now, after training the model, you can see that the accuracy reaches 65, 67, 69, and then it starts to drop and rise. So you can say that it is ranging from 67, around 67, yeah. But you can see that the accuracy for training started to reach 1 here at my 12th epoch, and then it stays 1 itself. So this basically tells that my model has already overfit. What this means is that either I have to, let's say, dumb down my model so that it uses a little less parameters and is able to generalize a little more, or I have to use even more data so that the model is able to generalize well. So with this we come to the second part of the first part of the course, where we have already built our own model. Now we will be using the mobile net model and see how to use that, since it is a pre-trained model, how to use that for image classification. So now we again start with the mobile net. So mobile net is aimed at devices with limited memory and computing power, such as mobile phones. The name kind of like gives it away. To reduce its footprint, the network uses DSC, linear bottlenecks, and inverted residuals. Now, these are actually very complicated terms, and if you want, you can search them up and understand what each of those means. But basically, what happens is that rather than just extracting information from the image itself through various layers, what we do is we comprise them of some of the convolutional 2D layers and some maxpool 2D layers, but we compress it rather than expansion, and with less amount of layers we are trying to find equally accurate predictions for image classifications, which MobileNet is actually able to do. Now, as I told you before also, this MobileNet has less parameters and less number of layers itself also. So what you have to do is type in this line of code to call in your MobileNet for the first time. So if you're able to write this, so what it does is it looks for the TensorFlow library package and inside that finds if there is any mobile.net or MobileNet uh, package or MobileNet file. If there is not, then it downloads it from its database and then you can start using the MobileNet. So for the first time, you must have an internet connection so that you are able to download the MobileNet file. You can see .h file is present here, and if you click on it, you can okay. So it's basically asking you to download only. Yeah, so it's only asking you to download. So you can see that an H5 file is present. That is basically the saved weights and classes for the or the information of the MobileNet that it has attained after training. Next, you can see that using the dot summary, we can understand how many layers are present, how many each of the parameters should be there, and lastly, the total number of parameters, which you can see is 4 million. And next, what we can do is now this is a really interesting part. So rather than this being just a pre-trained model, we can actually again retrain the model also. And if not, then we can actually retrain a particular set of layers itself. So you can see that I have taken the last six. So you can see here I have written how to choose till when to take the layer. So what you do is change the values here. So the number of elements that the number of layers that I'm taking is different. Then use my output layer after taking on the rest of the layers. Now we know that mobile and VGG16 both are functional model while we use sequential model to create neural networks. So before we were iterating all over layers from VGG16 to sequential model, now we are directly using the model itself. So when we were actually building our own model, we were going over each and every layer, training it again and again for all the epochs. While what we are doing here is rather than training all of the models, all of the layers, we're just taking out some of the layers and using them, or I should say, training them itself only. So you can see that I have taken this as my input and this as my output, this X. So I have given it the inputs are my input of my mobile net class, or I should say model. The output is again defined by me, not the default output of the mobile net class or model. So you can see that I've already specified there are 88 layers inside the mobile net and I'm only training the last 23 layers. So you can see that this is what it is telling me. That oh shit. I don't think it is going to run. Yeah, it won't be running. Yeah. Okay, let's move forward. We will see this later on. So you can see that I've again used the dot summary, and with this, you can see that the number of parameters have decreased. Meaning, I have changed the last 23 layers and trained them using only two classes. So that's why the total number of parameters have also decreased. Now, again, what I'm doing is just compile and training the model. But one thing to notice here is that we had the same settings for compiling both the model we made and the model we are using now, that is MobileNet. But you can see that the time that one took was much more as compared to the time mobile net is taking. It's only taking 5 seconds to 6 seconds for going over one epoch with the same size of the data set itself. But the thing is that the accuracy is very high. It starts off with 0.91, goes to 0.95, goes to 97, also 98, 96, 95. So you can say that around 96 is the average of the validation accuracy. And you can say that also that the model is also generalizing well because it has reached 0.99, and the validation accuracy has also not like decreased or is much less as compared to my training accuracy. So at this point we have just trained the model. Now we are using it to predict. So you can see that array has found of length 2. So if it is telling me 1 on the 0th index, it is telling me that it is a dog, sorry, a cat. And if this was supposed to be 1, then it would tell me that it is a dog. So you can see that, okay, yeah. So you can see that the value here is very small. Like you can say that this is close to 0. So from here we can see that since array of 1, meaning the index 1, is much smaller value, indicating that the model predicted it to be not a dog. So what I'm doing here is I'm just trying to get a dog. Okay. Oops, I made some wrong changes here. Yeah. So yeah, you can see that the 0th index has a value closer to 1. That means that the predicted class is cat. And if the value at first index is closer to 1, that means that the predicted class would be a dog class. Lastly, I'm just saving the model so that I can use this in my Flask framework for prediction. So with this, the first as a whole part has been completed, and now we will start working on the Flask framework. So this is the second part of the course where we will build and understand the Flask app. Now we start off with loading our deep learning model onto the Flask application itself. We have defined load model for it. So you can see that the model defined here, actually the function defined here is present, and the description says load model once at running time for all the predictions. So what's happening here is that we are actually trying to set the model into the session so that the model has to be loaded once and can be used again and again for predictions. Now session is something that is, let's say, holds all of the temporary variables that can be, let's say that, yeah, for a browser, you go into the browser and in the browser you search for a blog. Then you try to log in into the blog. Now once you have logged in, suddenly you close the browser. Now when you reopen the browser and go to the blog site, you would see that you are still logged in into the blog itself. Now what this means is that the session has already stored the value or the variable where it says that the person has already logged in. So unless the session is destroyed, you won't be able to log out if you are actually closing the browser. If you're just clicking on the logout button, yeah, then you can obviously log out. But so this is what session does. Session is basically holding all the data that is going to and fro from your server and client and storing it unless it is destroyed or unless the session times out. So similarly, we are loading our model likewise using the get default graph function. So what this does is makes a graph for all the computations that the model will be doing and stores it as a graph. Now, once this graph has been established, we don't have to load the model again and again, and you can use the graph itself. So that is what we are doing here, and we are calling our saved model. Okay. Then you can see the next function is predict function, which is taking actually the path of the file. This would be more clear later on. So you can see that the load image is taking the path and the target size. Now you might notice the target size is not 224. This is because I am not using mobile net. I have already trained a model, okay, and I am using that model. It is better than the model I showed you in the last part, but still doesn't, quite reach the mobile net power. But still, since it's my own build, I'm using that itself. So it takes the dimensions of 128 by 128, that is width and height, and then I'm expanding the dimensions accordingly for the model. And then you can see that from the graph, I'm now using my predict function of the model and predicting what class it would be, a cat class or a dog class. And I'm finally returning the result. So this is the part where all the rendering is being done for the Flask app, since above part was all the manipulation of the data. Here I'm just rendering the index.html page so that the first or home page of my web app can be shown. And if I go to the uploads, that is if I write in my URL, my base URL slash uploads, now it would ask me to go and get a file so that the I'm able to input a file or image, actually an image, I should say an image, that is a cat or a dog image. So once I get the image, I'm storing it into my uploads folder that I have defined here. You can see that I'm storing all the uploads to my uploads folder, and then I'm sending that path of the file from my uploads folder to the predict function and getting the result. Now from the result, if the value is greater than 0.5, I'm telling it that the label is dog or else it is a cat. And finally, I'm just asking out for the accuracy. Then I'm just finally rendering the predict.html and I would show you the prediction and the accuracy for it. So lastly, this is the create app function where I'm just starting with the loading the model and returning the app itself. So once I run this, so while this is running, let me just specify some things before you should start running the app itself. The first thing is create a new project folder. Second thing is, once you have created the project folder, install all the libraries that are required, all the packages that are required, or I should say all the dependencies that are required to run this project or run this Flask application. You can use the command onto your console, that is pip install -r requirements.txt. So you can see that is the requirement.txt here. So you have to run this command and all the dependencies would be downloaded and installed instantly and automatically. So you can see that it has loaded the model and the model is active. If I go to my link provided here, it opens my web application and asks me to upload an image. Once I upload the image, I can call out the predict function. Okay, so this is the second part where we are building a Flask application. And with this, I'm going to make some more changes, only a little bit, but yeah, some changes that are required so that I'm able to deploy this Flask application onto Heroku itself. So let's go to the third part of this project. At last, this is the third part of the course where we will be deploying our web application on Heroku. So before we start with Heroku, we have to understand that some files have to be made which are like commands for Heroku to understand. So let's start with runtime.txt and proc file. Runtime.txt is basically just telling Heroku which language or base it is that we are using for the server. So if you can see in the runtime.txt, I have defined that I am using Python with the version 3.6.13. Now, I didn't actually specifically tell you the version that I'm using, but for this application, a version of 3.6 and above won't work. Meaning, actually 3.6 would work, but 3.7 onwards it won't work. So if you're trying to run this application, try to run it on 3.6, any of the X versions, or maybe 3.5, 3.4, etc. Now let's come back to the proc file. So proc file is the mechanism for declaring what commands are to be run by your application in the Heroku platform itself. The commands that I specified in the last part, or I would say the commands that the Flask itself runs that are self-configured are actually what this proc file is telling to the Heroku that you have to run those commands also. I will show you some of the commands that are run and this line is actually what is making them all configuring itself rather than me manually setting up the server itself on Heroku. Okay, so now let's go to the Heroku. Yeah, so before yeah, actually before we go to Heroku, what you can do is upload the code onto your GitHub inside a new repo. Okay, and you can see that I have done that also, and my static templates, proc file, app.file, wgsi, wsgi are all inside my new repo, that is cat versus dogs. Now you can see what is this. Yeah, so now you can see that I'm onto my dashboard. And if you haven't actually got an account on Heroku, you can just simply log in or make an account. It is very simple. And after you log in, you can see that you would be specified or you would be getting the dashboard as the first page for your Heroku. And then you can just go to the new and create a new app. Here you can just type in any name. Okay, so this is not available and this is available. So you can just simply type the app name, choose a region. It only gives you two options and then create an app. So I've already created an app for this project. So I would be using that only. So once you create an app, you would be seeing that an app has been created here. And once you click on it, you would be getting this options of overview, resources, deploy, settings, etc. So what you can do is go to your settings first and there click on add build pack. So then you choose Python and go for save changes. Once you do this, now Heroku understand that you're going to use Python on your server and a build pack for that has to be instantiated there. Now click on open app. This is going to take time, but for you, there is going to be a default page showing that the app has been created, but since nothing has been deployed right now, so default page is going to be present here. So don't worry about anything. just go back to your deploy. Okay, so the deploy option, it is giving you three methods for deployment. That is using Heroku Git, using the GitHub, or container registry. Now this is for those who already know about DevOps and know how to build CIs. So for those who are just starting off with Heroku, what you're going to do is in your app connected to GitHub is going to give you an option of connect. So once you click on connect, what it is going to do is it is going to ask you to log in with your credentials onto GitHub. And once you do that, it is going to connect your GitHub with your Heroku account. And it is going to show you something like connected to your account name on GitHub. Okay. After that, it is going to ask you about your repository, which repository you want to connect with this app. So I've connected the cat versus dog, this repository with here. Now the next thing to do is go to manual deploy. Now in manual deploy, choose the branch. Since master was my main branch, I'm going to click on deploy branch. Now you can see that it has started working on setting up the server. Now this might take time, and while it is taking time, let me just clear out some things that I wanted to. First is, see, it is using the build pack that we have defined. Then it is saying that Python app detected. Now this Python app detected is actually from the build pack, and now it will start to understand which Python version to be installed on the server. And yeah, see, it is taking the Python version from runtime.txt, and after that it is starting to install all the setup tools or all the requirements from my requirements.txt. Now all of this is actually being supervised, I would say, from my proc file telling the server how to act and set up itself rather than me manually doing it. So it is now compressing the files, and this takes most of the time actually. So once this is done, hopefully it would the server would be set up and it would show you that the server is now active and you can start working on the or you can start interacting with the website. So we're going to wait for this, and it's now saying that it has done the compressing. And now you can see that it has launched. You can just take this link here, go to a new tab, and man, why does it take so much time? So yeah, it has now loaded the page. And now if I have to, and let's say I'm taking this as a sample, and I'll click on predict, and you can see that the prediction has been done. That is, it is a dog, and it is giving the percentile or the confidence of 100% that it is a dog. And you can go back to home, and from there again you can see and if you want to predict another image or not. So with this we come to the last part and have finished the last part, and here we will be ending our project, that is dogs cat versus dogs image classification.